Welcome back, Pre-Calc. We're going to be working on Chapter 3 now, which is all about rational functions. And what we have, as you can see, g of x is defined and it's pictured right here. And we can just look at the graph right now and we can identify some of the things. For instance, where g of x is equal to 0. As a reminder, those are where we have x-intercepts. So we're looking at x equals -1. So now we get a little bit of a different problem. Is we have a hole now at -3, if I'm counting that correctly. So when we're right where the function is above the x-axis, we need to take account, because if x is not defined, we cannot include it as being above the x-axis. So our answer here would be from -infinity to -3 union, from -3 to -1 union. It looks like from +1, again, we're looking where we're above the x-axis, to infinity. So then being below the x-axis, which is less than, it's not quite that easy. Well, I guess this one is really easy. We're just looking at from -1 to +1. As a reminder, these are your x values. Maybe I'll jot that down. We only care about the x values. So you don't need to write this down. It's just a reminder in case you forgot it from a unit ago. So we want the x values when the function is below the x-axis. Sort of how you read that. Now there's a big difference between this and the previous unit, because now we can be above or on. And typically we could just change everything to be brackets. Well, we still want -3 to be a parenthesis because it's undefined there. But from -3 to -1, -1 has a bracket. And then at x equals +1, it's an undefined value there. It's not on the x-axis, to infinity. So definitely not as easy to do this compared to the previous unit. And then the last one, again, -1 is on the x-axis, but +1 is that vertical asymptote. If you've heard that phrase before, let me write that down. So this point is called a hole, or I believe we have learned the phrase a point discontinuity. Sometimes we use the phrase a removable discontinuity. I'm not going to write that. Versus the vertical asymptote, is a non-removable discontinuity. Non-removable discontinuity. Now we also have a horizontal asymptote, but we're not learning that today. Just put that on the back burner. So how can we do this if I did not give you the graph? Because that's where we're going with this. Well, the first thing that they want you to realize is that you can plug in -3 in for these values. So g of -3. Now you want to be careful here. You don't want to put equals everywhere. I'll explain why. I hope I explain why, otherwise I might forget. So I'm going to do this quick math in my head. You can go to a graphing calculator to figure out these values. So just as a reminder in function notation, replacing every x in the problem with -3. What you end up with is 9 minus 12, so -3 plus 3, you get 0 on top. And on the bottom you get 9 minus 6, so 3 minus 3, you get 0 on bottom. Just a heads up, this is more for a calculus student, is if you were to write equals 0 there, or equals 0 over 0, this really doesn't mean anything. 0 divided by 0 has 3 different values, or 3 different ideas. Because a teacher might say, well, 0 divided by anything is 0. And somebody else might say, well, anything divided by 0 is undefined. So which one is it, 0 or undefined? And then you might get a third person that says, well, anything divided by itself equals 1. So now what is it? Is it 0? Is it 1? There's really no determinate value. So let me undo that. So right now, all we can say is this is indeterminate. Now we can definitely say g of -3 is undefined. Undefined because we can't determine what the actual value is. I hope that makes sense. Let me write that out. Cannot determine the value. And the real premise behind this, and you may go back to Unit 1 and think about it, is if we're dividing by 0, then it's no longer part of the domain. If it's not part of the domain, it's undefined. So that might be a better way of thinking of it. So let me change colors and do g of 1 now. And this one's a little bit more interesting. Or maybe it's less interesting. And if you're looking at the graph, you might say, well, at g of -3, that was the whole. If you're looking at g of 1, that's a vertical asymptote. Sometimes you write VA for that, vertical asymptote. But anyway, the reason why this one's a little bit more interesting is you actually get a value in the numerator. 1 plus 4 is 5 plus 3 is 8. I mean a value other than 0. Whereas in the denominator, 1 plus 2 is 3 minus 3. You get 0. Well, what happens if you divide by 0? This one is definitely undefined. And the premise that's going to happen is that if you plug in and you get some constant, so that constant is not 0, I'm using C for constant, divided by 0, that's your clue that it's going to be a vertical asymptote at that x value. At let me call it g of a at x equals a. But if you had g of b, some different value, equals 0 over 0, and if I heed my own advice, I'd put arrows there, that's your clue that it's a whole at that b value, x equals b. So these are pretty big ideas that I'm going to go into more details as we get further along in the unit. I think the answer key, as I'm not using the answer key, would probably talk about why dividing by 0 makes the outcome undefined. And that should make sense to you. I say it should because some of you might still be hazy on that. But how did we determine the domain of a problem? Well, the domain, I'll jot that down. The domain, we set the denominator not equal to 0 and solved. Well, that's essentially what's happening here. Is if the denominator equals 0, then it gives us, well, if it's 0 divided by 0, it's a whole. But if it's some other number divided by 0, you get a vertical asymptote. And one more thing is what they want you to notice with this bottom part on this front page is if you actually factored both top and bottom. So let me rewrite it right here. So g of x is equal to, well, the factor in the top would be x plus 3, x plus 1. And the factors on the bottom would be x plus 3, x minus 1. What you would notice, or I hope you notice, is the reason why you get a 0 over 0 is because those are the terms that factor out. So here's another hint for you. The factored out term is the clue for a whole. Now, what about the denominator? Well, if you look at the other piece in the denominator, I'm looking at this x minus 1, that was the one that gave me g of 1 up here. So where's g of x undefined is setting the denominator equal to 0. And where does g of x equal 0? We didn't even really mention that yet as analyzing this function, but let's go back up here. We had an x-intercept at x equals -1. Well, where is that located in my factored terms? Is the numerator set equal to 0 of the non-canceling term? So what do I mean by that? Is the canceling term I said this wrong earlier. I should go back and fix it, but I'm just going to say it right here. The factored out term that cancels. The canceled out factored term is your clue for a whole. And the reason why we need that statement in there is because I cannot have you say that x equals -3. This thing right here is where x equals 0, or where the function equals 0, because that's going to be a hole in the graph. So that's why the non-canceling term is in the numerator, is where your x-intercepts are located. And we're going to do a lot more examples, so if you're still confused, don't worry. The next page is full of examples. I'm going to try and work this out very similar to the way we did this before, because we already factored this. We already know everything. X plus 3, x plus 1. And we did something like this similar in the previous unit. And what I have my students do is put in all of those factors and the times that they repeat on your sign chart. This should be fairly familiar for you. And then put in your zeros. Remember how we set it up. And then to the left of those are going to be negative values. And to the right of those zeros are going to be positive values. And then, just like what we did before, we're going to multiply a negative times a negative times a negative times a negative gives me a positive. And then positive times negative is a positive. And then just one negative, positive times negative is negative, and then 4 positives gives me a positive. Now, this has a new feel to it, because a lot of students get in this habit of they look at this and say, or equal to. So maybe what I should have done is accounted for where these are numerators. So this is the 0 in the numerator, this is the 0 in the denominator, this is the 0 in the numerator, x equals -1, and this is the 0 in the denominator. So what actually makes more sense is to put an undefined value for where it's in the denominator, because remember, you cannot divide by 0. Same thing with this one. You cannot divide by 0, so this is not okay to be x equals 1. And the reason why I bring that to your attention is now when you answer where is the function less than or equal to 0, we're looking at negative values. I have students that want to say brackets -1 to +1 and a bracket with that. But the problem is if x equals 1, do you see how we'd be dividing by 0? So that is incorrect. It has to be a parenthesis with that problem. And let me circle that. This is your final answer. If you go back a slide, you'll see the graph and it matches our answer from there. Actually, the graph is right here as well. So that is confirmed from -1 to +1. It's on the x-axis at -1. It is a vertical asymptote at x equals 1, so you cannot include that point. It's an undefined value. So like right here is what we care about, being below the x-axis. So I'll leave it up to you to explain this in your own words. And please jot down any ideas you have. If you want to ask them in class, we can absolutely discuss it, but I have run out of time.